All right, let's dive in and unravel one of Java's most powerful concepts. It's kind of like a magic trick, one that makes your code way more flexible, smarter, and just easier to build on. We are talking about method overriding and dynamic method dispatch.
So we all know inheritance is awesome, right? It's a huge part of object-oriented programming, letting us reuse code like crazy. But what happens when a child class inherits a behavior that's just a little too generic? What if the parent's way of doing things just isn't the best way for the child? And that right there is our starting point. Before we jump to the solution, let's take a closer look at exactly why plain vanilla inheritance sometimes just isn't enough. I mean, think about it. A dog is an animal, right? That's inheritance 101. But if our generic animal class has a make sound method that just prints out the animal makes a sound, well, that's not super helpful for a dog object, is it? The dog needs its own very specific way to make a sound.
This brings us to our first big idea. When a child class needs to do its own unique thing, it uses a technique called method overriding. It's basically the child class saying to the parent, "Hey, thanks for the idea, but I got this. I know how to do this better for me."
Let's forget code for just a second. Imagine your family has this basic, default recipe for curry. It's the one everyone starts with, but you create your own special version. You keep the name curry, but you change up the ingredients. You've just overwritten the original recipe. Now, when someone asks you for curry, they get your special version.
In that curry analogy, it leads us straight to the official technical definition. Method overriding is simply the ability of a subclass, like our dog, to provide its own specific code for a method, like makeSound, that's already defined up in its superclass, the animal.
Okay, so let's see it in action. Here's our superclass, animal. Super simple. It's got one public method, makeSound, and it just prints a generic message. This is our basic family curry recipe.
And boom, here's the solution in all its glory. The dog and cat classes both extend animal, but they each give their own version of the makeSound method. The dog barks, the cat meows. Oh, and see that add override annotation? That's not just for show. It's a best practice that tells the compiler, hey, just so you know, I'm doing this on purpose, which is great for catching typos.
So, we've got that down. Child classes can override parent methods. Cool. But this sets up a really fascinating puzzle. And it's really the heart of what we're talking about today. When you've got multiple versions of the same method, who actually gets to make the call?
Now this is where the magic trick really starts. In Java, because a dog is an animal, we can do something that looks a little weird at first. We can use a variable of the parent type, animal, to point to an object of the child type, a dog. This code is totally valid.
And once we have that set up, we can just call the makeSound method on our myPet variable. Remember, the variable's type is animal, but the actual object it's pointing to is a dog. This is where things get really interesting. So, here's the million-dollar question. Which method actually runs? Does Java look at the variable's type, which is animal, and play the generic sound? Or does it look at the actual object, the dog, and make it bark? And even more important, how in the world does it know which one to pick?
Okay, time for the big reveal. The secret mechanism that solves this entire puzzle is one of the most powerful features in Java. It's called dynamic method dispatch. Let's unlock it.
Before we get technical, let's use another analogy. I love this one. Think of a universal TV remote. You've got one power button. The button itself is always the same, but what it does depends entirely on what you point it at. Point it at the TV turns on. Point it at the soundbar turns on. It's the exact same button, the same call, but you get a different action depending on the object.
And that is exactly what dynamic method dispatch is. It's the process where Java decides which version of a method to call at runtime, when the program is actually running, not when you're writing it. And here's the key. The decision is based on the type of the actual object, not the type of the variable that's pointing to it.
So when your program gets to that line, myPet.makeSound, the Java virtual machine does something really smart. It doesn't just look at the variable's type. It peeks behind the variable and checks what kind of object is actually sitting there at that exact moment. If it's a dog object, it runs the dog's version of makeSound. If we had pointed that same variable to a cat object, it would run the cat's version. The decision is made on the fly, dynamically.
Okay, this is the perfect time for a quick but super important clarification. What we're talking about here is method overriding. You might have also heard of method overloading. They sound similar, but they're totally different. Overriding happens at runtime between a parent and child with the exact same method signature. Overloading happens at compile time, inside the very same class, with methods that have the same name but different parameters. Two very different tools for two very different jobs.
All right, so this is a really neat trick. But why do we care? What's the point? Let's check out a real-world application to see how this power lets us write some seriously elegant and scalable code.
Imagine we're building a little graphics app, like a simple paint program. The game plan would be pretty simple. First, you'd make a generic shape class with a draw method. Then you'd create specific subclasses, like circle and rectangle, that each override that draw method to do their own thing. And finally, this is the awesome part, you can just throw all these different shapes into a single list.
And just look at how clean this code is. We can have an array of shape objects filled with circles, rectangles, whatever. Then we just loop through it and call s.draw. That's it. We don't need a single if statement checking if it's a circle, do this, or if it's a rectangle, do that. Dynamic dispatch handles it all for us. And if we want to add a triangle shape later, we just create the class. This loop doesn't have to change at all. That is what scalable code looks like.
Now, this magic is incredibly powerful, but it isn't chaos. It actually follows a very strict set of rules, and the Java compiler is the referee. To use this feature correctly, you've got to know the rules of the game.
So here's the cheat sheet. The method signature, the name and the parameters, has to be exactly the same. You can't make the access level more restrictive. You can go from protected to public, but not the other way around. See a method marked final or static? Can't override it. And of course, constructors aren't part of inheritance, so you can't override them either. Stick to these rules, and please use that @override annotation, and your code will be solid.
If you remember just one thing from all of this, let it be this, the golden rule. At compile time, when you're writing the code, the compiler looks at the reference type, the variable, to decide what methods you're even allowed to call. But at runtime, when the code is actually running, the JVM looks at the actual object to decide which version of that method is going to run. One decides what you can call, the other decides what will run.
So there you have it, method overriding and dynamic method dispatch. They aren't really magic at all. They're just a brilliantly designed system for achieving polymorphism, and they let us write code that's cleaner, more flexible, and way easier to extend. You've seen how the trick works. The only question left is, what are you going to build with it?